Yes, we'll wait for others to join. So last class we had discussed about the concentration. Okay, the strength, how to determine the strength of solutions, different expressing how to express the different concentration of solution in terms of molarity, right? Molality, then mole fraction, mass percentage, volume percentage, right? So we had discussed that, and then we had solved some problems. So now we'll be starting with solubility. Okay, so we'll be starting with solubility. So solubility, what do you mean by solubility? So it is the maximum amount of substance that can be dissolved in a specific amount of solvent at a specified temperature is called its solubility. Okay. So whenever you are seeing the solubility, what do you mean by solubility? So how much amount of maximum amount? Now, when you want to dissolve sugar, suppose sugar, you have taken water. Okay, water is a solvent. Sugar is what? Sugar is a solute. If you add sugar to the water, okay, and you try to mix it, you try to dissolve it. So the maximum amount of substance that is dissolved in the solvent, okay. So that it is getting soluble. So whenever you're talking about solubility, so it tells you about the maximum number of substance or the solute that can be dissolved in a specified amount of solvent, okay, at a specific temperature. So at a specified temperature, then it is called as solubility. So solubility of a substance is its maximum amount that can be dissolved in a specific amount of solvent at a specific temperature. So it's called as what? It is called as solubility. Now this solubility, okay, when you're talking about solubility, on what factors the solubility depend? It depends upon the nature of solute. Okay, it depends upon the nature of solute. Okay, then it depends upon the temperature. It depends upon the nature of solute, then the solvent which is present, as well as the temperature and pressure. So what are the factors on which the solubility depends? The temperature, so first it depends upon the nature of solute. So what type of solute you are taking, okay, what type of solute you are taking to dissolve in the solvent, then it depends upon the solvent, okay, the type of solvent, then temperature, what is the specific temperature, and what the pressure is you are applying for during the solubility. So these are the factors which it depends upon. So next we'll see the solubility of a solid in a liquid. Okay, when we are talking about solubility of a solid in a liquid, so suppose you take a solute. Okay, so when you take a solid solute, okay, and what you are doing, so what means what your solid is your, so solubility of a solid in a liquid means what your solute is solid. Okay, so here so when we are checking about solubility, okay, so here the solid is your solute. Okay, solute is solid in state and solvent is liquid in state. Okay, so so when you're talking, just a second. Okay, so when you're talking about so when you are checking about the solubility of a solute, that is a solid solute in a liquid solvent. So suppose you have taken a solid solute, okay, solid solute you have taken, and that you have added into a solvent. Solvent is there, okay, in that you are adding the solid solute. Okay, so what happens? So it dissolves. Okay, you dissolve the solid into the liquid. So example, now water you have taken, and if you add salt, so salt, what happens? It dissolves in the water, right? So same way the solid solute will get dissolved in the solvent. Okay, and what happens? What will happen to the concentration? Concentration of water will remain same. Suppose you have taken a plain water. Okay, plain water. So plain water first. Okay, then later you add salt in that. So will the concentration of the water change? Yes, it will change because you have added salt, right? The concentration will change. The same with respect to this. Okay, the concentration of the solution, it will change. Okay, the concentration will increase. Okay, concentration is increased. Why? Because you have added a solid solute. So this process of dissolving the solute, okay, solid solute in the liquid solvent is called as dissolution. What it is called as? Dissolution. Okay, So it is called as dissolution. What is dissolution? So when a solid solute is added into solvent, when a solid solute is added into solvent, it dissolves and the concentration increases. Okay, what will happen to the concentration of solvent? It will increase. Okay, so in the solution, so the concentration increases in the solution, and this process is called as dissolutions. Okay, so this is called as what? It is called as dissolution. So at the same time, what will happen? If the solute particles, what will happen? They will collide with each other. Okay, collide means what? They will get so collide particles. So it will collide. Collide means they will hit each other. Okay, collide means it will hit each other. So at the same time. So at the same time, the solute particles, they will collide with each other, and what will happen? It will get precipitated. Precipitated means what? It will form a salt-like form. Okay, you will get a curdy PPT. It is called as PPT. Okay, curdy PPT-like form. Okay, and this process, when your solute particles, okay, when your solute particles start colliding with each other and it will get precipitated, this is called as crystallization. Okay, so this is called as crystallization. So when crystallization occurs, so when so at the same time, when your solute particles will collide with each other and it will get precipitated, it will form a curdy precipitate like. Okay, precipitated means what? Your salt, it get dissolved. Okay, and the salt, okay, it forms a salt like this. Okay, so it is called as precipitated out of the solution, and this process is called as crystallization. So after crystallization, what happens? If you leave it for some time, okay, after the precipitate is formed in the solution, and if you leave for some time, the concentration of solute will increase. Okay, whatever the solute you have added, the concentration of the solute will increase. Okay, so a stage a stage will be reached. Okay, now a stage will be reached where dissolution and crystallization occur at the same rate. Okay, so at the same time, so when so after some time, so after some time, what will happen? The concentration of solute increases, and this at the same stage, what will happen? It will reach the dissolution and your crystallization. Dissolution and crystallization, they will be occurring at the same rate. Okay, at the same rate, and the solute particles will be going into the solution will be equal to the solute particle which is crystallizing out. So whatever the solute particles, solid particles, okay, solid solute particles will get dissolved in the liquid particle. That is however it is getting dissolution, how much amount it is getting dissolved, that much amount it will get crystallized out. Okay, and this dynamic equilibrium is reached. Okay, so there is equilibrium. Equilibrium is what? The amount of solute which you are adding into the solvent, how it is getting dissolved, the same amount it is getting crystallizing out. Okay, so like this, it is called as the, it will reach a equilibrium. So that is solute plus solvent. So when you add solid solute into solvent, it will so with equilibrium, it will form solution. So such a solution, okay, so such a solution in which no more solute particles can be dissolved at a specific temperature. So after some point, the number of solute particles which you're going to add in the solvent, it will stop. Okay, it will not get more dissolved. So at that particular specific temperature, then it is called as saturated solution. Saturated solution means wait, what? In a particular given solutions, if you add solute particles, okay, and the solute particles now at a particular stage, or the solute particles, most of the solute particles get dissolved, okay, in the solution. So now no more solute particles get dissolved. Okay, so that is called as saturated solution. So saturated solution means what? It contains maximum amount of solute. Okay, so the maximum amount of solute, it get dissolved in a given amount of solvent. Then it is called as what? Saturated solution. So thus the concentration of solute in the saturated solution is called as its solubility. So this is about the solid solute in the liquid solvent. Okay, so what you need to remember, what is dissolution, what is crystallization, what is solubility, and what is saturated solution. Saturated solution means what? Your solid solute is there. Solid solute, so when no more solute particles get dissolved in the your solution. Okay, so that is the maximum amount of solute get dissolved. Okay, the maximum amount of solute get dissolved in a given amount of solvent. So that is called as a so the specific temperature, at a specific temperature. Okay, so then it is called as a saturated solution. Okay, so this is about the your solubility of a solid in a liquid. Okay. So nature of solute and solvent, polar solute dissolves in polar solvent and non-polar solute dissolved in non-polar solvents. So like dissolves like, so you know that polar solvent means what? Polar molecules means what? So polar molecules means HCl, for example, HCl. Okay, so this is HCl. So chlorine is highly electronegative atom, so it will tend to pull the electron towards itself. As a result, it will get partial positive, partial negative. So this is a polar bond. Okay, non-polar, for example, H2. Okay, for example, H2. So this is a, so it will, so it is having a so it is a it will undergo homolytic cleavage, right? So equal amount of electrons are distributed among two. So this is a non-polar bond. Okay, there is no any electronegative atom. So always the polar solute dissolves in polar solvent and non-polar solute dissolves in non-polar solvent. That is like dissolves like. So this is about the nature of solute and solvent. Okay. Next is effect of temperature on solubility. So in general, if the dissolution of salt, okay, dissolution process of salt is endothermic. What do you mean by endothermic? Yes. What do you mean by endothermic? Heat is released or heat is absorbed? Endothermic. So it involves the absorption of heat. Okay, absorption of heat. So always, so whenever the dissolution process of a salt is endothermic, okay, if it is endothermic means what? Absorption of heat. Okay, it results in the absorption of heat. Then the solubility will increase. Okay, it will increase with the increase in temperature. So as the dissolution process of a salt is endothermic, then the solubility increases with the increase in the temperature. That is, so it will be positive. Okay, it will be positive. So here you can see if the dissolution process is endothermic, then this, okay, so the solubility increases with the rise in the temperature. So this is the effect of temperature. Then second one, so the examples for this is dissolution of ammonium chloride, then sodium nitrate, then potassium chloride, then potassium iodide, then AgNO3. Okay, so these are the examples for your endothermic reactions, for your endothermic reaction. Now, if the dissolution process is exothermic, okay, if it is exothermic, the solubility decreases with the rise in temperature. Okay, it decreases with the rise in temperature. So whenever you have exothermic reactions, what will happen? It will be negative. So this will be positive delta H, and delta H will be negative in terms of the exothermic reaction. Okay, so what will happen to the solubility? So solubility will decrease with the rise in the temperature. And what with respect to endothermic, it will increase. The solubility will increase with the rise in the temperature. So this is about the effect of temperature. Okay. So next we'll see what is the effect of pressure. So effect of pressure on solubility. So solids and liquids are highly incompressible. Okay, solids and liquids, they are highly incompressible. Means what? It is very difficult to incompress. Incompress means what? To compress, to put pressure. So pressure, okay, solids, so pressure, you cannot put pressure on your solids as well as in liquids. Okay, so gaseous molecules, if gas is present in a beaker, and if you can easily compress it, you can easily put the pressure, but you cannot put a pressure on solids and liquids. Okay, so solids and liquids are highly incompressible, means they cannot be compressed, and they remain unaffected by change in pressure, and thus the effect of pressure on solubility of solids in liquids will be insignificant. Okay, so on solids and liquids you cannot apply the pressure, thus it has no significant effect. So it does not have any significant effect on solubility of solids in liquids, as they are highly incompressible. Okay, it cannot be compressed. Okay, it is highly incompressible. So this is the effect of pressure. So as solids and liquids, they cannot be compressed. Okay, so pressure, so pressure, it does not, you cannot apply any pressure on that. Okay, so this is about the effect of pressure. Next, we'll see solubility of gas in liquid. Okay, what is the solubility of gas in liquid? So solubility of gas in liquid is affected by pressure and temperature. So here your gas will be a solute, and so that is your solute particle will be gaseous in state, and your solvent will be liquid in state. So what are the factors which are determining this? So first we'll see what is the effect of pressure. Okay, what is the effect of pressure? So what is the effect of pressure? So solubility of gas. Okay, when you're talking about the solubility of gas, what will happen? It will increase with the increase in the pressure. So whenever gas is there, you know, gas molecules, they can be easily compressible. You can easily apply pressure on that and it can be compressed. So whenever you are talking about solubility of gas, okay, gas molecules are there, so it will increase. Okay, it increases with the increase in the pressure. So this relation is given by Henry's law. So this, when you're applying pressure to the gas molecules, it is given by a law called as the Henry's law. Okay, so what does Henry's law state? So Henry's law states at constant temperature, okay, the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas. So at constant temperature, remember this word, at constant temperature. So at constant temperature, the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas, or it can be also the partial pressure of a gas in vapor phase is proportional to the mole fraction of the gas in the solution. So any one of the statement you can write for Henry's law. So you know that whenever gas molecules are there, that can be, when if you apply pressure, it can be easily compressible. Okay, so it is called as the it is given. So it is given in terms of the, it is given in terms of Henry's law. It is given how? It is given in terms of Henry's law. So at constant temperature, so the pressure, partial pressure of the vapor of a gas in a vapor phase is proportional to the mole fraction of the gas in the solution. Okay, or at constant temperature, the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas present above the surface of the liquid or solution. So if the solubility is expressed in mole fraction, okay, so so this is in terms of what? So this is in terms of the statement before was in terms of partial pressure. Okay, now if the this here the this, okay, this particular statement is given when it is, when you are expressing in terms of mole fraction. Okay, when you are expressing in terms of mole fraction, the statement will become the partial pressure of a gas in the vapor phase is proportional to the mole fraction of the gas in the solution at constant temperature. So here you mention at constant temperature in a solution at constant. So whenever you want to, so any one of the statement you can write for Henry's law. If you want to write in mole fraction, then you have to write like this. If you want to write for, okay, the other one, so you can write that. Okay, so this is the way you are going to write. Now, so according to the statement, okay, according to the statement, so according to the statement, pressure is directly proportional to what? pressure is directly proportional to the mole fraction. So mole fraction is given by X, right, at constant temperature. So mole pressure is given by X at constant temperature. Now, when you remove this proportionality sign, okay, if you remove this proportionality sign, you have to introduce a what you have to introduce a constant. Okay, so here the constant is given as P is equals to kh into x. So kh is called as a Henry law constant. It is called as the Henry law's constant, and it is different for different gases at particular temperature. So this is different for different gases at particular temperature. So higher the value of kh at given pressure, the lower is the solubility of a gas in a liquid. Okay. So higher the value of kh, higher the value of the kh at a given pressure, the lower is the solubility of a gas in the liquid. So as the value of kh will be more, okay, if the value of the kh is more at a given pressure, the lower will be the solubility of a gas in a liquid. So this is the Henry's law. So kh, it depends upon what? It depends upon the nature of gas. Your Henry's law constant, it depends upon the nature of gas. So the nature of gas, if it is different, the different gases will have different nature of gas. Okay. So at particular temperature, it will show different this. Okay. So this is about the Henry's law. So now, just a second. Okay, Henry's law. So if a partial pressure, so we'll see a graph. Okay, so if a graph of a partial pressure, if you plot the graph for this partial pressure of a gas against mole fraction for this particular statement, if you plot a this, okay, for partial pressure against mole fraction, against mole fraction, uh, then the nature of graph will be like this. So from the origin, it will go, okay, it will go and it will have a slope like this, A, B, C. Okay, so slope is given as what? Slope is equals to AB by BC. Okay, AB by BC, this slope is nothing but your Henry's law constant. Okay, so it is different for different gas. So this is the plot. This is a plot for Henry's law. Okay, when you are taking partial pressure versus your mole fraction. Okay. Next. So from Henry's law, it follows that at a given pressure, higher the value of kh, lower will be the solubility of gas in the liquid. So whenever you're talking about Henry's law, so from Henry's law, what you come to know that at given pressure, okay, if the value of here, okay, at a given pressure, if the value of kh is more, what will happen? The solubility will be lower. So this is very important. Keep this note in mind. So higher the value of kh, that is a Henry's constant at given pressure, the lower is the solubility of a gas in a liquid. Okay, this is about that. So therefore, as the temperature increases, in the value of kh for both the gas increases and hence their solubility decreases. Okay. So this is with respect to different gases. Now we'll see some of the applications of Henry's law. Okay, we'll see some of the applications of Henry's law. So Henry's law applications, the first application is to increase the solubility of carbon dioxide in soft drinks or soda water. The bottle is sealed under high pressure. So you know, okay, so when you are okay, for your soda bottles, okay, for your soda bottles, it will have what? Carbon dioxide. So to increase the solubility of carbon dioxide in soft drinks. So in soft drinks, you know, carbon dioxide gas will be there, or soda bottle. Okay, so carbon dioxide will be there. So the bottle, it is tightly sealed with what? At a high pressure, it is tightly sealed. So this is the first Henry's law, this, okay, application. Then second is in deep sea. Okay, in deep sea, divers will be there, right? That is the scuba divers. You talk about scuba divers. So they breathe under very high pressure underwater. So you know, okay, in the sea, during sea, when you're going in dip, okay, that is a deep divers. In divers, okay, so the breath under high pressure underwater. Okay, they breathe at a very high, so there is requirement of very high pressure underwater. So at higher pressure, what happens? The solubility of atmospheric gas, Okay, in blood, what will happen at a very high temperature or very high pressure? What will happen? The atmospheric gas which is present in the blood, it increases, and but when they come towards surface, the pressure gradually decreases, and the dissolved gases comes out in the form of bubbles of N2 gas. Okay, N2 gas, which blocks the capillary. So this is the action of your this in during the sea dives. Okay, when you're sea divers. Okay, so this medical condition is known as bends. So which is painful and dangerous. So this is very painful and this is very dangerous. Then at a high altitudes, okay, when you go in the on the mountains, suppose you when you go on the mountains at a very high altitude, the partial pressure of oxygen is less. So as you go at higher heights, okay, at higher heights, what will happen? The oxygen level will go on decreasing, okay, as that compared to your ground level. So now if I'm present here, so the oxygen content here, and when you go at very top level, okay, the oxygen content will be varying. So this leads to what? This leads to low concentration of O2. So if you are present at a very high altitude, okay, so in your body there will be very low concentration of oxygen, okay, in the blood and tissues of people who are living at high altitudes, which causes anoxia. Okay, anoxia. So whenever so some of the people who stays at the very high altitude, so the what happens, the concentration of oxygen in their blood and tissues will be less. Okay, so because of that they will have this called as anoxia. Okay, these are some of the your this. Okay, you had attended last class, Nagalambika. You had attended last class.
Yes, ma'am.
Yeah. Okay. Uh, last class we had solved. Where are others? Others they have not joined. They are not joining now. So based on Henry law, okay, we'll solve two questions. So there are two questions based on Henry's law. So if you have a book, please note down. I'll just write the question and we'll solve the question. Okay. So if N2 gas, if okay, if N2 gas bubbled through water at 293 Kelvin, how many millimoles of N2 gas would dissolve in 1 liter of water? Assume that N2 gas exerts a partial pressure of 0.987 bar. Okay, and here what is given is your Henry's law constant. Okay, Henry's law constant for N2 at 293 Kelvin is what? It is 76.48 kilobar. Okay, so this is given. So given is your Henry's law constant. So what they have asked, if N2 gas is bubbled through water at 293 Kelvin. So this is 293 Kelvin is a specific temperature. How many millimoles of N2 gas would dissolve in 1 liter of water? So assume that N2 gas exerts a partial pressure of 0.987 bar and Henry's constant of N2 gas at 293 Kelvin is 76.48 kilobar. Okay. Now, you know, as per Henry's constant, okay, that is Henry's law, how it is given, P is equals to KH into mole fraction X. Okay, so now what we want to find? We want to find the mole fraction. So X, okay, X is equals to pressure. We know what is pressure and we know the Henry's constant, it is KH. Okay, so what is pressure? Pressure is 0.987 by 76.48. So this is bar and this is kilobar. Okay, so bar and bar get kilo means you can write in terms of into 10 raised to 3. So this will be 0.987 divided by 76.48 into 10 raised to 3. So solve this and see what answer you are getting. 0.987 divided by 46.48. Yes. It will come to 0.0129. Okay, and 10 raised to 3. So when it goes above, it will become 10 raised to minus 3. So this is the mole fraction. Now mole fraction, so that is mole fraction of N2. Okay, E is equals to what? It is given as 1.29 into 10 raised to. So just I am rearranging it. It will get 1.29 into 10 raised to minus 3. So I am just moving the decimal to front. So if you are moving to right hand side, you are going to add here. So it will be 10 raised to minus 5. Okay. Now, therefore, mole fraction of N2 by N2 plus water. Okay, so now we are going to find the mole fraction for N2. So N2 is what? N2 is 1.29 into 10 raised to minus 5. Okay, so what is for water? How do you find for water? Mole fraction for water. Mole fraction for water. How much water is taken? 1000. Okay, 1000 liter. 1000 liter means 1000. You can take in terms of gram. And what is the molecular mass? It is 18 gram per mole. Okay, 18 gram per mole. So this comes to what? 1000 divided by 18, it comes to 55.55. Okay, so now therefore N2 by mole fraction of N2 plus H2O. Okay, now you know what is the molar this for H2O. I can just this now, right? So what is molar mass of H2O? It is 55.5. It is what? 55.5 is equals to 1.29 into 10 raised to minus 5. Okay, so now understood till here? Okay, I'll just rub the question. Okay. So here, so after this, we are going to solve further. Okay. So N, so that is number of moles of N2 divided by, so you know, for since N2 will be very less, okay, then H2O. So this will be, we are not counting it, it will be 55.55. Okay, is equals to 1.29 into 10 raised to minus 5. So N2 is equals to, so just take this here 55.55 into 1.29 into 10 raised to minus 5. Okay, so after taking this into, this will be 71.659 into 10 raised to minus 5 moles. So they have asked in terms of what? They have asked in terms of millimoles. Millimoles means what? You have to subtract it by -3. Milli means 10 raised to -3. Okay, milli. Milli is 10 raised to -3. So what will be the answer? Answer will be 71.69 into 10 raised to -2 millimoles. So this is the answer. I hope you have understood. Yes. So we are relating in terms of mole fraction, right? So we are going to take mole fraction. We are going to find the mole fraction of water into, and we are going to add whatever we know, and then we are going to solve it. So this is about the problem. Okay. Yes, understood.
Yes, ma'am.
Okay. Try solving this now. I'll give one problem. The partial pressure over a saturated solution containing 6.56 into 10 raised to -2 grams of ethane is 1 bar if the solution contains 5.0 into 10 raised to -2 grams of ethane. What shall be the partial pressure? What shall be the partial pressure of the gas? Okay. So try to solve this. So you have to apply the Henry's constant. Okay, pH. So you know this is given in terms of what? Not mole fraction. So here the mass of the gas is taken in calculation. So mass of the gas is directly proportional to the partial pressure at constant temperature. So taking that, you have to solve this. Yes, try solving this. Try solving this. Yes. Okay, you can solve this later. So next we'll go for the effect of pressure. So this was, we were discussing about the effect of pressure. So next we'll go about the effect of temperature. Okay, that is solubility of gas in liquid. So next is effect of temperature. You have to solve this. Okay, solve this. In next class, we will discuss. So we had discussed about the effect of pressure. Now we'll discuss about the effect of temperature. So generally the dissolution of gas in a liquid is exothermic process. Okay. So hence what will happen? So the solubility of gases in the liquid will decrease with the increase in temperature. So whenever you are talking about the effect of temperature, so when you are talking about temperature in terms of solubility of gas in liquid, so you know that the dissolution, okay, the dissolution of the gas in liquid is exothermic. Okay, so exothermic, so there will be release of this. So exothermic reaction means there will be release of heat. Okay, So because of that, so what will happen to the solubility of gases in liquid? It will decrease. The solubility of the solubility of gases in liquid will decrease with the increase in temperature. So this is the effect of temperature. So vapor pressure of liquid solution. Okay, so next we are going to go with the Raoult's law. So before going to Raoult's law, so what? So Raoult's law, it talks about the vapor pressure of liquid solution. Okay, so consider that is vapor pressure of a liquid solution. So both the solutions are liquid. So that time we are talking about the vapor pressure of liquid solution. So let us consider a binary solution of two volatile liquids. So if you take a binary solution means what? A solution consisting of two different solutions. Binary means two. Okay, binary means two. So let us consider a binary solution of two volatile liquids. Okay, what do you mean by volatile? Volatile liquid. Volatile means what? Easily it gets evaporated at normal temperature. Okay, what do you mean by volatile? Volatile means the liquids gets easily evaporated. For example, ether. Okay, for example, alcohol. So these liquids easily they get evaporated. So whenever so what you consider binary solution, that is two solutions with two volatile liquids. We'll consider it as A and B. If we consider two liquids A and B, two volatile liquids, two volatile liquids, what? A and B. Okay, so what they are done, they have taken in a closed container. So in a closed container, so this is closed. So in a closed container, so two closed container are taken. So in this two container, what is taken? Two liquids, volatile liquids. So why it is closed? Because it will easily gets evaporated, right? So because of that, the both the liquids A and B is taken in a closed container. Then both the components evaporates and a equilibrium is reached between the vapor phase and the liquid phase. So as the liquids are liquids are highly volatile. So what will happen as the liquids are highly this volatile, they gets evaporated, and it will reach a equilibrium where your vapor phase and the liquid phase will be in equilibrium to each other. Okay, so the total vapor pressure, so when you are talking about the total vapor pressure here at this stage, that is it is calculated as P total. So P total and PA and PB. Okay, P total is what? It is a total vapor pressure, and PA and PB is the individual vapor pressure of liquid A and liquid B. So this is a individual vapor pressure. So this is vapor pressure of A and this is a vapor pressure of B. Individual vapor pressure, partial vapor pressure of liquid A and B of the solution respectively. Now, if you consider the mole fraction XA and XB, if you consider the mole fraction XA and XB, so these are what? This is a mole fraction for A liquid and this is a mole fraction for B liquid. Okay. So when you're talking about mole fraction, so this is for XA is mole fraction of liquid A and this is mole fraction of liquid B. Okay. Then the relation between the partial vapor pressure and the mole fraction of the component, it is given in terms of Raoult's law. So here, so when you are comparing your liquids, okay, that is your volatile liquids in terms of the partial vapor pressure and the mole fraction. So in terms of partial vapor pressure, you are talking about partial vapor pressure and the mole fraction, then it is given in terms of Raoult's law. Okay, what it is? Raoult's law. So we'll discuss about the statement and remaining part we'll see in the next class. Okay, so what is the statement? Raoult's law. Raoult's law states that for a solution of volatile liquids, okay, for a solution of volatile liquids, the partial vapor pressure of each component of the solution is directly proportional to its mole fraction to that component present in the solution at a given temperature. So this is the Raoult's law. Okay, Raoult's law. So Raoult's law, what does Raoult's law states? And that for a solution of volatile liquids, the partial vapor pressure of each component of the solution is directly proportional to the mole fraction of that component present in the solution at a given temperature. Or it can also be given as for a solution of volatile liquids, okay, the partial pressure of each component in the solution is equal to the product of its mole fraction. So depending upon the mathematical statement itself, I have told you the statement. Okay, so Rawls law, what it states that for a solution of volatile liquid, the partial vapor pressure for each component. Okay, this is partial vapor pressure for each component. So P01 and P02, these are the vapor pressures. Okay, so vapor pressures, partial vapor pressure of each component in the solution is directly proportional to the product. Right? This is product of its mole fraction in the solution and the vapor pressure of its pure component at the same temperature. So these are the statements for Rawls law. Okay, this is a statement for Rawls law. So for component A, how it is given, PA is directly proportional to its mole fraction. So PA is equals to XA into P naught A. What is P naught A? P naught A is the partial vapor pressure. Okay, P naught A is a partial vapor pressure. Now, similarly for component P. Okay, this is similarly for component B. Partial vapor pressure is directly proportional to mole fraction into its partial vapor pressure. Okay, so here P naught A and P naught B are the vapor pressures of the pure liquid A and liquid B at the same temperature. So this is about the Rawls law. Okay, understood till here? Yes.
Yes, ma'am.
So if you have any doubts, you can ask me. So this is about the Rawls law. Okay. So Rawls law, whenever you are talking about dissolution, dissolution is what? Dissolution means the amount of solute which are going to dissolve in the solution. Okay. So that is dissolution. So dissolution is an exothermic process. So as a dissolution is exothermic process, so according to Le-Chatelier's principle, the solubility should decrease with the increase in temperature. Okay. So the Rawls law, what is the statement is very important. Henry's law also, the statement is very important. From exam point of view, Henry's law statement is important. Rawls law statement is important. And the mathematical representation. Okay, and you have to remember the mathematical representation also. So in the next class, so just we'll see the mathematical this. So according to Dalton's law of partial pressure. So if you apply the Dalton's law for this partial pressure, the total vapor pressure of the solution is given by P total. Okay, P total is equals to PA plus PB. Okay, PA plus PB. So substituting PA and PB. If you substitute PA and PB, now what is PA? So that is P total is equals to PA into XA. Okay, okay, dot XA plus PB dot XB. Okay, so if you take P naught A, this common 1 minus XA plus P naught B 1 minus XB. So since you know mole fraction of sum of mole fraction of all will be equal to 1, right? The sum of mole fraction will be equal to 1 since sum of mole fractions, all mole fractions will be equal to 1. So it will be P naught A minus P naught A into XA plus P naught B into XB. Okay. So P total is given by P naught A plus PB minus P. Okay, so this, if you want, I'll again explain in the next class. So I hope, so just remember till here. Okay, just remember till the Rawls law, Dalton's law of partial pressure. Again, I'll explain in the next class. So if you have any doubts, you can ask, or we'll end the session here. Yes. Okay then. Thank you. We'll stop the class here. Okay.